You see, this dimension is not matching with this. There is nothing, x can be anything. So you cannot say that, 1x is always equivalent to 2, 1. Okay. So this is where there is a huge mismatch. Okay. Okay. So, and what I'm taken by surprise is that, when I see similar mistakes, I mean, here also it's pretty similar. So then I kind of wonder are people copying from each other? Okay. When I see this similar kind of mistakes. Okay. And that any teacher will get suspicious that, students have been copying from each other. So that's not a good thing. It just hinders your own learning. Okay. So please do avoid. Okay. Okay. And now the other thing which I would like to say is, I mean, when you do stuff like this, okay, here, this one also I want to share. Okay. See, in the previous one, it was not at all clear to me whether, you actually use the tiles to factorize or you factorized in the standard way and then tried to rearrange the tiles. There is no way for me to figure that out because I did not see you do it live, right? But if I see something like this, then it seems there is more chance that, somebody who has done it has used the tiles. You can see this 0 pairs and all those things. Okay, I'll come back to this question. Okay, or if you see this, there is a very clear thing that, the connections are very clearly shown here. Okay. Yeah. Okay. Now, this one again, very, very clearly shown. In fact, the borders have been made, so it becomes extra clear what your factors are and how you are getting. That part is very nicely done. However, do you think this one is correct? Okay. Can you identify the issue here, the problem here?
So we have to get positive 3, but we're getting negative 3. Negative 3.
No, that is see, in the same zone, see what happens is, if you have this mix now, see here, you have opposite ones, right? So this part is fine. Okay. Now, if you consider this part, then what should be here? Positive or negative?
Positive.
Exactly. Now, if this is positive, then again, this part will be what? If this is positive.
This is also positive, but we have to rearrange everything like same order. For example, positive, I put everywhere positive. Negative,
yes.
Everywhere.
Yes. So, I mean, this one should be like this, these 3. They should have been positive and these should have been negative. I hope the convention is clear. Oh, sorry, the other one. These should be positive and these 3 should be negative. Okay. And then with that, if you add, the positive here and this negative one here, I'm not going to add all, but I'll just add the 4 corner ones. Okay. See, if you do this, then the border becomes much more reasonable. Okay, but you see here there is a lot of confusion. Okay, so remember that each zone must have the same color. Okay, 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 so same thing has happened here too. Okay, so you see, the moment you do this now, how will these borders match up? There is serious problem there, you know. See, this is negative, then how will this be positive? Okay, so something becomes wrong. Okay, so I hope this part is clear. Okay, okay. Now this is a good question. Okay, why add zero pair? Now the thing is, without adding the zero pairs, acha, before I get into that, would anybody else want to answer this question? Why do we need to add zero pairs for this factorization?
I cannot map that once.
Louder, please.
Can you hear me?
Yes.
I cannot map that once, all the ones with the 3x only.
Yeah. So that is one thing. Without using the zero pairs, there is no way for you to, you know, it's impossible to complete this whole rectangle. Okay. Because you have to make this rectangle with these 4 different zones, and that's impossible. The other thing is, if instead you are doing, see, the factorization is a reverse process, like subtraction, like division. The direct process is the multiplication. Now, if you multiply these two, okay, the picture will look exactly like this. And remember, in that case, we removed the zero pairs. So since we are doing the reverse process here, we need to add the zero pairs. Okay. Whenever the constant term is positive, you see these two we will have the same sign. In this case, both are negative. Okay, let me just. Yeah, so in this case, you know, this is positive and both of them are positive, right? And in this case, it is positive, but both of them are negative. Okay. So whenever it is, the constant term is positive, the x, all the x term, it splits into 2 of the same sign, either both negative, because then negative time negative gives you positive, or both positive. Okay. But if one of them is positive and one of them is negative, then obviously positive times negative or negative times positive, that will give you a negative. So these two will have opposite sign. These two zones will have opposite signs, and therefore they will generate zero pairs. Okay, that's another way you can think of it. So zero pairs will be generated the moment you have a negative constant term. Okay, and therefore you bring in zero pairs. Does this answer your question, Sri Bhavani?
Yes, Swati, but I couldn't. And if children ask the same question to me, means I'm not clear about to say for this reason only we are adding zero pairs.
Okay, so let me see if this will make more sense. See, first of all, when you do the multiplication thing, you will see that we always end up getting 4 different zones. Okay. And the zones are kind of like this. you will have x square here. Okay. And then you will have x. You will have x's here. And you will have the ones here. Okay. No matter what you do, even when you did multiplication of 2-digit numbers, there are these kind of clear zones. In that case, you will get hundreds here where we now have x squares. You will get tens where we have x's and the ones are there, right? So this structure is very, very common. Okay. Even for decimal multiplication, the similar structure comes out. Now, in that case, so then now let's look at the borders. Okay. So maybe I will use a different color. Yeah. Okay. So now the factors come here, right? So factors will come here and they will be of the form x, and then this will be in terms of ones. Similarly, some x's here and some ones here. Okay. Now, okay. Now, if this is negative, okay, suppose this is negative. This is made of negative ones. Sorry. Okay. That means one of this, either this is -1 or this is -1, right? So without loss of generality, if we take the first one as the top one as -1, okay, then you see here, you will get, sorry. Okay, I'll take care of that. Here you will get -x, because this thing will be negative and this is positive. So you will get -x here and you will get +x here. So between these two zones, you will have zero pair, right? Is this making sense?
Yes.
Yeah. So there's no way you can avoid zero pair. Okay. Because the only, see, you will have, when you are doing middle term factorization, the constant term, okay. Okay, let me write this out. Let's now take, it will be of this form, right? Let's first take the simple bit. So we are going to write it, we are going to factorize it into this way, right? So you see, this automatically means that B is nothing but negative of P plus Q, and C is nothing but P times Q, right? So you see this thing, whatever is here, that negative number is to be written as a product of two numbers. Now, whenever you want to write a negative number as a product of two numbers, one of them has to be positive and the other has to be negative. They cannot both be positive. Neither can they both be negative. So that is where here, one of this will be P, another will be Q. One of them will be positive, another will be negative. And immediately, and here both will be positive because x square is usually always positive. So automatically, these two zones will have different signs and thereby generate zero pairs. Okay. Are you comfortable with this explanation?
Yes.
Okay. So thank you for asking this, raising this question. Okay. Okay, didn't anticipate that. Okay. Now, okay, now we have to go to division, but before that, I want to ask one thing. You see, as long as the leading coefficient is x square, it's very clear what is happening. Okay. And you can see that, that whole, this is the B which needs to be split into P plus Q, that kind of comes in very clearly. But when we have something like and let me take a general example. Okay, so this is like the second, third, and the fourth examples that we have. Then life becomes a bit more complicated, because now this will need to be written as let's say px plus q, okay, times rx plus s, okay. Now, in that case, now let's see what happens. So what we get is that A is nothing but P times R. Similarly, C is nothing but Q times S. Okay. And B is PS plus QR. Okay. Now, if I now map this onto what we do, so here are the borders. Okay. And then we have the zones. And what we get in each zone are, so here we will have ax square, okay, which is nothing but PR x squared, okay, and this place will have C, which is nothing but QS. Okay, so this part is pretty clear. Now what happens is, so here we will have something like PX. Here we will have RX. Okay. Now, depending upon what A is, if A is, let's say 6, then P and R can be 1 and 6, or 6 and 1, or 2 and 3, or 3 and 2, right? Kind of two possibilities. But if A is something like 12, then there are lot of possibilities. Okay, much more possibilities, and you have to basically check each possibility. Okay. Now, similarly, if the C is QS, then this one, so one of these two has to be Q. So this one will be, needs to be Q, and this one needs to be S. Okay. So, and then consequently, and if we have, if this will be PSX, sorry, this will be QRX. QRX, and this will be PSX. Okay, and everything you see can kind of fits in together, right? So these two together add up to give you BX. Okay, so now what happens is we basically factorize A and we factorize C and then try to see which combination generates this. Okay, what do we do in the standard algorithm? The traditional way, we multiply A and C, right? And then we try to find two factors, in which case the factors in this case will be PS and QR, such that B is nothing but PS plus QR. Now, when I'm writing plus here, I'm treating PS, QR, etc., all of these as integers. Okay, so that's why the plus itself just works. Okay. Now, can you see there is a similarity between the two processes? Okay. Because with the algebra tiles, you are breaking each one into smaller ones because you are actually dealing with smaller numbers. Here, the moment you multiply, you are getting into bigger number, right? And then again, you have to factorize. Here, when you are working with this, you don't need to multiply them, but you do need to factorize. Okay. So in a sense, you are dealing with smaller numbers. You are doing the same process of factorizing both. And once you get it, because ultimately you need the PQ and the RS for your final answer. And this, when you work with algebra tiles, it directly gives you those rather than in the traditional way. Okay. Is this making sense?
Yes, sir.
So those of you who haven't attempted all these questions where A is not 1, A is more than 1, you can now try to think of it this way. Okay, so where you factorize A and then you factorize C, and then you kind of take one, and if you try to put it in this form, maybe you may find it easier to understand what exactly is happening. Okay. Okay. So now let us go into division. Now I'm very glad to see that somebody has attempted division. Okay. Yeah. So Sri Bhavan is the only one who dared to divide. Okay. She did get stuck. And can somebody point out where she has got stuck? Okay. One thing is when you do this, okay, in the standard algorithm at this level, you need to subtract. Okay, so here you need to change sign for both. So it's a negative 6x square minus 3x. So then the 6x square and the negative 6x square, they cancel. And there you have minus x, you will have minus 3x. So together you will have a different thing here. Okay. What I will do is I'm going to now demonstrate this using this.
Can you hear me?
Yeah.
Can you share the PPT? We couldn't see.
Hang on. Okay. Can you see now?
Yes.
Yeah. So see here, this 6x square, let me just annotate it. So this should be, the signs should have changed here. Okay. So this, you need to subtract this. So then, these two cancel out and you end up getting not 2, but a -4. Okay. What I will do is, you see what is happening is the 6x that you have here, 6x squared, those 6x squares are accounted for. But you see here you have a -x and suddenly you have got so many, that's not matching up. Okay. So that's the part where we need to look into, and I'll demonstrate this with the help of the virtual manipulatives. Okay. So let me do that. I have jot down the problem, 6x square minus x plus 5. So let's get those tiles. Okay. So we have got 6x squares. Okay. And we need x. Okay. Or -x, sorry. -x. And we need 5. So 1. Okay. Now we have to put the border here, so that we will do x, 2x plus 1. We are dividing by 2x plus 1. So that's 2x plus 1. Okay. And then let's align these things first. Danger of okay. So we are done with the x squares. So correspondingly, what will come on top? On top, we will get this, right? So, yeah. So what I want to do is I want to make another, let me see what can be done. Okay. I'm going to write the process simultaneously. Okay, I'm going to attempt that. Okay. So we are dividing by 2x. Okay, let me make the font better. Okay, I hope this is visible. So we have got this. Okay, and here we have got 6x squared minus x plus 5. Okay, and the quotient I will write on top. Okay, so now at this level out here, we have got 3x. Okay, now if we have 3x here, down here we will have 6x squared. Now we need to bring, it's a 1 and then x, so we need 3 x's here, right? But we have only a -x. So what do we do? And this is a question to you. We need 3x here. All we have is a -x.
So 4 minus 6.
So we bring in 0 pairs. Okay. So here is 1 0 pair. and then we are going to replicate them. Okay. Now, okay, I could have taken the horizontal ones. That's fine. Okay. So this becomes, right? Okay. Now we come to the next step. Okay. So we subtract. I don't think, okay, I'll try to draw a line somehow. It's not going to be nice, but it will work. Yeah, that does the job. Okay, maybe I should put another line here also, just so that we know what is going on. Yeah. Okay. So now when we subtract, what are we left with in the traditional way? We are left with negative 4x. Oh, sorry. Wait. This should have been a plus. Then we change sign. So I'm just going to put the signs here. So we have a minus here and put a minus, right? So once we change sign and then subtract, we get negative 4x. Note that that's exactly what we have here, right? And this 5, of course, is there because we haven't done anything with the 5. Okay. So now what we need to do is we need to align these here. Okay. So here we go. And now we are done with the x's. Okay. So what comes in the quotient part now?
-2.
Negative 2. So let's get negative 2. That's 1 and that's 2. So now we can put here minus 2. Okay. Now, if we have got negative 2 here, so here we should have negative 2, positive 1. So we should have, what should come here?
Negative.
Negative 2. But we only have positive ones. We don't have negative ones.
0 pair.
Again, we get 0 pairs. So here is 1 0 pair. Replicate and use the, use the negative ones here. Okay, so that's done. So we get minus 2, and that's exactly what we have subtracted. And then again, a sign change. Oh, sorry, here it will be 5, plus 5. Sorry, this should be plus 5, negative 2, sign change. And then so the 4x and negative 4x and plus 4x was cancelled in the standard algorithm, and we are left with 7, right? Plus 5 plus 2, 7. Notice that that's exactly what we have left here. Okay. That's exactly what we have. The remainder. Okay. That's 7. And you see, you can clearly see whatever is happening here. You see, you got the negative 4x before, I mean, it automatically came here, right? And now you can see the 7 almost exactly as 5 plus 2. Okay. So, okay. So here we go. Okay. So this is the quotient. This is the divisor, as you know. This is the quotient. This is the divisor. This is the array, which is nothing but divisor times quotient, and then this is the remainder. And notice that this, whatever we put in here, okay, that and the remainder, they were both basically, we started with the dividend, 6x square minus x plus 5. And we didn't add anything to it but 0 pairs, right? So the whole dividend got split into this two parts, this array and the remainder, and the array is divisor times quotient. Okay. Did this make sense?
Yes.
Okay. If anybody has any doubt, this is a good time to ask. So since none of you did the divisor homework, I would like you to do those two for before next week. Okay, so that's the ongoing homework. So here's a question. So there were two questions. Okay, if I remember correctly. Let me just quickly check. Okay. Oh, okay. Sorry. Yeah, so this was the homework. So I gave you just two problems for division. So if you want, I can give you more. Okay. Or you can do just two. So what do you want? And if you want, I can give you a few more on factorize also. Over to you guys.
I think two should be fine for now. I think two should be fine for now.
Yeah, I know. Now the schools are open. You have more work to do, etc. So, okay. So the division part of the exercise remains. And those of you who didn't do all the factorize, please complete them. Okay. So that would be the homework. And so I guess from now on, we will be meeting at 12, right? Not 11 on Fridays.
Yes, okay.
Okay. So I have updated my calendar, no further confusion. The other thing is, so this is what we did in terms of algebra. What next would you like to do next?
I had a question.
Please go ahead.
How do you explain negative into negative multiplication to children?
Aha. Okay, I believe we did do that at a long time ago, but I can definitely revisit this. Okay. Okay, so okay, I'm tempted to put it as a homework, but that's okay. Let me not be so evil. Okay. Actually, let me close this. Save. Okay. Okay. So when you do negative times negative, what I'm sharing is exactly what is there in NCERT textbook, class 7. Okay. So, so I'm going to go about it this way, and people may consider doing it slightly differently. That's fine. So this is how I prefer writing my multiplication table. Some people may write it slightly differently, and that's fine. Okay, and that's how it continues, right? Okay, now if you want to put a row here, what will come here? Okay. Okay, so this is what we have. Now my question is, what will come here?
Zero into 4.
Yeah. Okay. Next question. What comes here?
-1 into 4.
How? And how much will, okay, -1 times 4 is kind of obvious, but how much will it be?
-4.
-4.
I know, but what is the logic in that? How do you justify that?
All of them are decreasing by 4, 4. So
Fair enough. Okay. So you can think of it on the number line, etc. You can see this pattern. Okay. What is happening as you go up, and you can see that, it's basically reducing by 4 each time. So therefore, you take away 4 from 0. That's what happens. Okay. So it will be nice if you you can show it on a number line, what is happening, because that will help them visualize this. Okay. Okay. And then you can basically extend the table this side. Okay. And what happens, see, if you are considering, say, 3 times 4, it's 3 jumps to the right. But if you want to go -3 times 4, then it will be 3 jumps to the left. Right? And you realize it will be -4, then -8, then -12. So this whole notion that, so you get a sense that -3 times 4 is equal to negative of 3 times 4. Okay. So that thing kind of emerges from this. Okay. And again, this 3 and 4 can be anything. So different children can, students can pick different numbers and explore, and it should be the same thing. Okay. Next. Now, suppose you want to make the table of negative numbers. Okay. Now that is possible. So what you need to do, it will be similar like this. 1 times, that's a -4 equals -4. 2 times -8, sorry, 2 times -4 is going to be -4 plus -4 equal to -8. 3 times -4 equals -8 plus -4 equals negative 12. Okay, and you can continue this way. Okay. Now, again, the same question as before. So this way you get all the, so in this way you get a sense that, okay, so 3 times negative 4 is going to be basically, negative 4 plus negative 4 plus negative 4. So it's again going to be negative of 4 plus 4 plus 4. Okay. So this thing emerges, this thing kind of, this emerges. Okay. So you have got both these rules. Okay. That negative times positive is negative and positive times negative is negative. Now, all we do is we extend the pattern. So what comes here?
Zero into negative.
Exactly. Okay, and there are many ways to discuss why it should be 0, right? And now you can guess where this is going. So what comes before that?
Negative 1 into negative.
Yes. And so here you get negative 1 times negative 4, and then you need to ask, how much is that?
4.
And you have to ask, why is it 4? So it's very important to ask these questions and ask why.
So if you consider from down,
Right. The answer.
Okay. Again, it's just simple pattern. As you are moving up, it's increasing by 4. So if you follow that pattern, that's exactly what is happening, right? This movement is the same as, moving like this. So you are going from negative 12 negative 8, negative 4, then you went to 0. So then afterward, like you are literally jumping like this. So the next jump has to be like this, and it has to land here. You are just following the pattern, and that's it. Okay. Now did this help?
Yes.
Yeah. And you can ask the child to read up this textbook also. As I told you, class 7 integer chapter, it is there. There is another way to visualize this as well. We do not have time now, so remind me to share that with you next time. Okay. So I have shared it before. I am pretty sure of that, but that's okay. It has been quite some time. So
graph method or some other method.
And that way, this one is not going to work for rational numbers. That other method, okay, or that model, that way of thinking about multiplication, that extends to rational numbers and real numbers. Okay, so so that can be done. So I'll show that to you next time. Any other question?
Hello, Shwati, can you hear me?
Yes.
I have a question. For normal division, while I'm doing that, when I ask my student to divide 21 by 2, they can orally say that when I divide 21, I'll divide 22 2 times 10, 10, and then that one I'll divide half, 0.5, so it is 10.5. So when I ask them to do by that long division method or by cancelling it, when I say the remainder is 1, so for
Hmm.
remainder 1, I have to keep a dot and add 0 here. So it becomes 10, it will be 5. So it gives the answer 1.5 in the case of 21. I can't explain, I don't know how to explain that. If that is 21,
Okay.
this one will be 0 and again a point will be there.
Okay, so I'll see. I don't know if I'll be able to do justice in 2 minutes, but I'll try. Okay, so for that, we'll have to get here. Okay, see, now we will get into, okay, how do I, okay. Is there an easier way to clear this? Okay, this works good enough. Go. So now we go to algebra tiles to something else. Okay. I miss my own things. Okay. So I'm going to ask you to stretch your imagination a bit. Okay. Please do that because I don't think they will have something like, no, it's only bars. No, they don't have anything for decimals. So, okay. So now what will happen is typically this will be 100. But since I want to get into decimals, oh boy. Okay. No, I think I will just draw it out. That will be easier. Okay. I hope you can. You can see the whiteboard, right?
No, Swati, I can't. No, now I can. Okay.
Okay. So let's draw it out. Okay, because nothing else will do. Okay, so this is, let's say 20. Okay, and this is 1. And you are dividing this by 2, right?
Yes.
So you arrange it like this. And let me draw some borders and stuff. So this is the border. Okay. And so here is the 2. Okay. That's what you are dividing by. Now you have got this thing left. Okay. So this is the, oops, sorry. So this 1 of 21 is left, right? So what you do is, so, okay, let me also do the text version. What we really do is, so we are dividing by 2, 21, and okay. Now you have distributed 20 and therefore you have got 10 here. Okay, so far so good. Okay, and let's add that minus. So then you have got, you are left with 1. Okay, this is where we are. Okay, now what do we do? This 1 needs to be split into 2, right? So what we do is we exchange this 1 into 0.1s. Okay, so they will be like this. And there will be 10 of them. Okay.
Swati, here itself they are just putting 1 and 2. 2 times is 2. 1 time is 2. That 0 won't come here actually. We are just
It's
bringing.
not, hang on, wait. It's not a question of not come. Please put it. Okay, otherwise the child will remain confused.
Okay. So we should ask.
Because in the standard algorithms, we crunch things too much and the meaning goes out of the window and children remain confused forever.
Okay.
So please write that 0 because it's a 10. Okay. If you use arrow cards, then you can superimpose on that, etc. But at least to begin with, write that 10. Okay. Otherwise, it will be very confusing. Okay. So this has been exchanged with 10 0.1s. Okay. Now, these can be distributed here. So I'm going to move them. Okay. So this one comes here. Sorry. Okay. Let's see if I can manage this. And yes, thankfully that worked. Okay. Don't. Okay. Now see, here we had already got the 10, which I haven't drawn yet. So let me draw the 1. Okay, we have got the 10. Now, see, now what do you have? You have got the 0.1s here, right? And so you have got exactly these things. So I'll have to draw them again. There's no copy paste or duplicate as far as I know. So, you know, there will be this. Right? So in other words, you get 0.5 here. So 0 point, that's exactly why you are going to put a 0.5. Okay. And what happens here is, here we just put a 0. Okay. And then we write a 10 here and then we subtract. Okay, just bear with me a bit. Okay, so this is what we do. Now, this 10 is that there are 10 of them. That's what it indicates. There are 10 and each of them is 0.1. So that's why there is a 0.5 because there are 5 of them in each row.
Okay.
Okay. And this is why there is, so when we extend it, it becomes 10 this way. Okay. And you may want to, okay, so since you asked this question, I'm very tempted to give you one small homework. Try dividing, this is very small homework. Try dividing 3 by 4. Okay, in the same manner. Okay, if you don't want to do 3 by 4, you can do, let's say 7 by 4. Okay, so homework is this. Try 3 divided by 4 or 7 divided by 4 this way. Okay, so 2 algebra division and 1 number division, and they are very linked. Okay, so as usual, we have gone past time. If you have any other question, we can take it immediately or we can try it for next week.
We can meet next week. Okay.
Yeah. Okay. I'm sure you guys are also hungry by now. I am. So I'm going to stop sharing. Okay. So see you next week.
Thank you.
Bye.